Here's a simple circuit consisting of just a resistor and a light-emitting diode. I'd like to investigate the voltages in this circuit, and I can do that easily with a digital voltmeter. I'll set it on its 20-volt voltage scale, and I can measure the voltage across the LED. If I do that, maybe I measure, I'll indicate that measurement over here, maybe I measure 1.81 volts. Or I can equally well measure the voltage across this resistor. And that resistor is, say, 3.2 volts across that. So this symbol with that I've indicated in pink here is a quick way of sort of as if I measured the voltage. It doesn't mean that I necessarily put my voltmeter there, but the symbol kind of looks like a voltmeter. It's I've measured the voltage across this resistor. We'll give it a name R1. And if I measured the voltage from here to here, of course, I'd get 5 volts. And you see that the sum of these two voltage readings is 5 volts. That has to be. So voltage readings are really convenient in that way. Current readings are another matter. If I want to measure the current through here, now current is the voltage is across, but the current is through. And so current, it's the same current here and the same current here. It's got to be, whatever it is. Maybe it's 14 milliamps. I don't know. But whatever it is, it's the same current here as here. My digital voltmeter also has some current scales. You can put it on, say, the 200 milliamp current scale. There we are. But it doesn't do any good. You can't just put your voltmeter probes or DVM probes across an element and hope that you're going to measure the current through it. It doesn't work. In fact, you'll see that right away if you try it. Go ahead. Here's this LED that's lit up. There's evidently some current through it. It's the same current as through that resistor. As soon as I go to measure, if I put my current scale across that, the LED goes out just as I do that. So I know something's wrong. The meter is reading a number, but the LED is off, and so you know that it's evidently not reading correctly the current that's going through the LED. So currents are going through. If you want to measure a current, you have to intercept the current, which is very easy to do on a blackboard. All you have to do here is make a hole in one of these traces and take that digital voltmeter and use it as a current meter to measure the current that's going through. So if 14 milliamps is going here, now it has to go through the meter and gets read, and then it gets reinserted into the circuit. But that's kind of a pain in the neck on a real breadboard, because what was that you did? You actually had to find some place where you could pull a piece of wire out and replace it with the leads of the meter. A much better way to do it is this. Let's leave the circuit intact. Get rid of that voltmeter, or that current meter. And instead, I'm going to just go and use my regular voltmeter to read the voltage across this resistor. Why read that voltage across the resistor when what I really wanted was the current through the resistor and the current through the LED? Easy. If I read 3.2 volts and I know the resistance value, maybe it's 1,000 ohms, I can just use Ohm's law and say that the current through that resistor has to be 3.2 volts divided by 1,000 ohms, which is 3.2 milliamps. So I've inferred the current through the resistor and the current through the diode ever so much more easily than trying to actually go physically measure the current. When does that process work and when doesn't it work? So maybe I've got another circuit and it has 2 LEDs and a resistor in the middle here. And I'm curious, what is the current through these LEDs? Well, it's the same as each other. They're in a row. Any current that goes through one has to go through both. But there's this convenient resistor here, and I can just measure the voltage across it. Maybe it's 1.1 volts, and maybe it's a 3.3 kilo ohm resistor. And I can again compute the current through this, the current through this, the current anywhere along that string, simply as 1.1 volts divided by 3.3 thousand ohms, whatever that turns out to be. Here's yet one more example, and it's a bad one. So suppose I have 3 LEDs in a row. You could do this. They light up just fine. And I'd like to know the current. It's the same current through this one, and this one. I could go and measure the voltage across one of them, maybe that one, maybe another one. But it's not a resistor. What am I going to do with that information about the voltage? I could take that LED out of the circuit and measure and put a ohm meter across it, and I'll get some number, but that won't actually be the resistance of the LED. LEDs don't have a resistance. They don't obey Ohm's law. So in this situation, if I want to know the current, I'm really going to have to make a hole. I'm going to have to interrupt the current flow between some of these components and go right ahead and insert an actual current meter in order to measure that one.